Thanks for taking the time today to attend my presentation, The Automation of Spatial Data Validation. This is work I did as a contractor supporting the USGS at the Denver Federal Center in Lakewood, Colorado. Started this work about 2 years ago, and it continues to this day. The NHD is an integrated hydrography data set across the contiguous USA as well as now into Alaska. It is a very large data set that is being used in many applications, including resource management, farming, other sorts of agriculture, ecosystems management, water resources for urban areas, industry, and so forth. It's a 1 to 24,000 scale nominally, although certain states such as Indiana are making a lot better quality, or I should say a lot more precise data sets. The NHD data sets have been around for many years. They are generated by data stewards across the various states and territories, and then integrated and brought together and added to by USGS staff within the NGTORC, the National Geotechnical Operations Center. As these data sets are adjusted, the NHD Plus is regenerated, sometimes every couple of years, sometimes longer, depending on the number of changes when the threshold is reached. Before these data sets can be released to the public, they need to be validated to make sure that they meet all the hydrologic rules, they're valid data, the geometric networks are integrated and correct, and things of that nature. These are large data sets with, for instance, about 25 million records in just one feature class, the NHD flow line in the lower 48th alone. The previous manual validation took inordinate amounts of time, depending on the size of the region, or the HUC4, Hydrologic Unit 4, and often was only just spot checks of the data. When I was originally brought on to aid the USGS as the contractor, I was a GIS architect, but the focus of my work was broadened when it was seen that I was flexible enough to provide solutions to a variety of technical issues, coding, the ability to find new technologies, and so forth. Along the way, I've looked at things like GeoPackage as a data set format that can be used for a public environment, the open source that everybody's looking to move towards, and so forth. One of my tasks was to research, prototype, and write validation scripts to make sure the data is properly validated efficiently in a timely manner without inordinate amounts of resources being used. These scripts were going to be and are indeed being integrated into a production environment, including, as we will see later, the most recent in-house generation of the data sets with validation proceeding after every step. Manual testing utilized a spreadsheet with multiple tabs, one for each step, A, B, C, D, and so forth. I took a copy of this spreadsheet and turned it into a pseudo Kanban. In a sense, it is also where the pseudo code is kept, because the hydrologic logic, effectively the same thing, that has been generated by the hydrologist and myself, that bridge between the science and the scripting, is also retained here, and as you will see later, is also integrated into the scripts themselves so people can follow along. The spreadsheet also keeps track of the status of a particular script, whether the logic is available, whether it needs to be scripted, whether the script needs to be revisited in one of the iterations that might be related to the data sets being slightly different than expected, and things of that nature. This is a very useful resource and indeed is being used, as we will see later, as this validation is brought into the .NET environment of the data generation production, a more integrated environment using current software development lifecycle processes and modern approaches. The manual data validation worked on stepwise data sets, file databases derived from the HUC4 data set for each of the HUC4s. These ranged from step A through step T or thereabouts, with some gaps in between. These were generated by Model Builder, and that continues to be the process. Currently, I'm looking into, along with some of the hydrologists, about bringing these Model Builder models into Python, as they can be quite complicated and difficult to maintain and structurally difficult to understand. This will also tie further into the aforementioned use of NHD validation in-house as part of the production process. The datasets, as those of you who have used NHD Plus might be aware, consist of vectors, lines, points, and attribute tables, both attached to the individual vector datasets and separate attribute tables. Examples of the polylines might be the NHD flow lines, polygons might be the water bodies, point datasets might be gauge stations, for instance. The main example of standalone attribute tables are what are known as the VAAs, value-added attributes, that tie back to the various vectors in various ways by the NHD Plus ID, in a sense a primary key. This is the main way that scientists, water resource planners, and people of that nature can use applied science to utilize the NHD Plus fully within their working environment. I started on this process around 2 years ago, back in 2018, and have slowly integrated more and more scripts. Even then, though, I decided that ArcGIS Pro was a better approach than the existing, at that time at least, 10.x desktop environment, which was the main resource being used. The USGS, at least within the NG Talk, is a Esri shop, hence the choice of software platforms. The ability to view the data and generate the scripts within one software platform, in this case ArcGIS Pro, has been very useful in terms of generating these scripts, both the science and the application of the science. My IDE of choice behind ArcGIS Pro is PyCharm, if you are curious, and it integrates very nicely within this environment. The ability to also readily transport and share these data sets, these scripts, these toolboxes with other people within our environment is also very useful. Software, and indeed scripting and automation, has no inherent value. We need to tie it back to the hydrologic science driving the validation. This is done by generating hydrologic logic, as we've been calling it, and then breaking out individual steps to tie together the science and the scripting environment. This is done with the aid of a hydrologist, myself, and a series of iterative back and forths, making sure that things are not missed. On occasion, we might return to the hydrologic logic and hence the script to ensure that any dataset allowances, indeed any structural allowances that have been changed or weren't expected in the first place, are accounted for and taken care of within the validation. Documentation is always important, but more so within this sort of environment where we have many subject matter experts across the team contributing to this automation process. The idea is that any one of the team within their skill set can look into a script, into any part of the process, such as the pseudo Kanban we had earlier, and pick up where others have left off with no real loss of excellence. To this end, the various parts of the hydrologic logic are included as comments within the script. These scripts are generally quite linear, and so as we break apart the logic into individual steps, we can then code against that logic and then move on to the next piece to be coded. As the scripting proceeded, I realized that some of the scripts were fine within the Esri environment, as it were, but some scripts were not able to run in an efficient fashion, especially related to time and computer resources, so I explored other options. For the VAA testing, that is the tabulated data testing, initially I tried using NumPy and then extended that further with pandas. In the future, in terms of the vectors, I might look at using GeoPandas or maybe the spatial data frame. More about that later. Continuing with this idea of autonomous research and then learning, I've looked further into various other approaches to make sure these data sets can be validated in a timely fashion. One example here, for instance, is taking advantage of ArcGIS Pro's parallel processing geoprocessing tools. The specific example here is the dice and then the pairwise buffering to allow for the large data sets at least vector-wise, that some of these data sets contain. Some of these scripts, even with the performance improvements, take some time to complete due to the sheer size of the data sets, the number of vertices specifically, and or the number of attributes and attribute combinations that need to be checked and hence validated. So keeping the user informed is a vital part of the process. As an aside, this environment, this output to the user, will be less and less seen as this is brought into the production environment. So we are looking at other approaches that we will discuss later to keep the user informed. As the user may not get to see the script output window, and so there is an ongoing record of what the scripts produce and generate, a check table is generated within each step database. As you can see here, there are a number of conditions. There is a pass, obviously a good thing. There is a fail, where the data sets themselves are incorrect in terms of the hydrologic logic. The hydrologist may circle back to see why this is the case. The script might be adjusted, the data may have to be reproduced, or underlying problems with the data set explored. Sometimes the script fails. This is maybe due to it encountering circumstances we did not expect. Say, for instance, a table name was changed somewhere along the way by a developer or someone of that nature, and the script can't find the data set or the table name. Another example is manual checks. These are circumstances where there is a very rare occurrence of something, and to write a script to allow for it would not be efficient. Therefore, a manual check is flagged, and the hydrologist and or the script writers can go back and look at how best to approach this. The check table noted in the last slide records details of all scripts run against that stepwise database. However, sometimes we need to account for and record why a data set has failed. Therefore, tables are generated as needed and uniquely on a date-wise basis for a particular script run, outlining details of where it failed in the hydrologic logic, for instance part 2 in this example, some of the numerics or the data sets or the unique identifiers such as NHD plus ID, and a brief description of how and why it failed. The hydrologist can then go back to the data sets and look further and explore how and why these data sets failed and how to best approach it. Keeping metrics of how these scripts are working is an important part of writing these scripts for two reasons. One, to make sure that the scripts are actually performing efficiently and are being worthwhile. And two, to be honest, to relay to management how much better a scripting environment is than, say, a manual process or some hybrid model. As you can see on the table on the left, the Esri methods versus NumPy versus NumPy plus pandas generated marked speed increases and also used memory. Other examples are using parallel processing, allowing a script to run, say with a dice model where previously it might have failed because the number of vertices was too large. On a regular basis, charts, data sets, reporting, etc. are generated for management in terms of planning and so forth. A lot of the validation to date, as mentioned, the 75 plus scripts, has been related to attribute-based data, the VAAs, the value-added attributes that are used by many scientists and so forth. Moving forward, I am looking to do more validation of vector-based data. One possible approach is using GeoPandas. Another is using the spatial data framework that's available in ArcGIS Pro 2.6. The reason for doing this is that we can then stay within the standard or default environment of ArcGIS Pro, meaning that IT doesn't have to set up different environments within a production environment or a so forth. There might be other approaches to doing this work. I'm still exploring this. This year I was involved with ArcGIS Pro 2.6 alpha and beta testing of the trace network environment. This is going to be very useful for us validating the network environment, the geometric network environment of the various data sets being generated, to make sure that we have continuity, stream flow, and there's no gaps in the data sets, for instance, after a data set a data steward adjusts things. I've already written a script as another approach to look for duplicate vertices that might be generated in the artifact process. We have noticed between SDE environment, the enterprise environment, and the file databases that precision is slightly different. We're guessing this, but in the meantime, there are multiple vertices, less than 10 millimeters, that are adding to the size of data sets unnecessarily and with no return. Looking to remove these, so hence the script being written. The NHD plus high resolution data production is being brought in-house. Previously, it was generated by a contractor and sent as HUC4 file databases. The validation was then completed, and if any data set irregularities were noted, the source data sets were adjusted and then pushed back to the contractor for the HUC4s to be regenerated. This could be a time-consuming process, as well as maybe not being the best use of resources. Therefore, it has been decided, as the NHD plus high-resolution data production is being brought in-house, as mentioned, that the data validation should be integrated directly into the production environment and the data is validated after every step. Therefore, if a step, say C, has a data error, the data error can be addressed, step A, B, and C can be run, rather than step A through T or U, for example. This integrated environment is going to use .NET as a wrapper, but all of the Python scripts will be exposed. Therefore, they can be added to, adjusted, edited, etc. as needed as the validation automation process, script generation continues ongoing. NWIS, gauge, and associated tabular data sets are utilized by NHD Plus for calibration. The tabulated data sets might include length of record, flow rates, flow heights, and things of that nature. Currently, this is done manually, and therefore I am looking into whether I can scrape the web pages to contribute to each HUC4 to help calibrate the data sets. As usual, this would reduce any potential human error, take less time, if any time, in terms of manual approaches, and also ensure that we have the full data set. So to summarize, these scripts are now being used in a production validation of the generated NHD Plus high resolution data sets. They're efficient and they're indeed viable, checking the hydraulic validity, and they're in contrast to the previous manual checking where you might get 2% or even less in some occurrences of the data sets. The process and the models allowed for designing, building, and testing, and then adjusting of these scripts as needed, and they are being used for further production testing and scripting. Also, as noted, the validation scripts will be an integrated part of the data generation process, allowing for increased efficiency of generation, ready for their release to the public. Further, some of the techniques I discovered, as it were, during my autonomous testing, research, and self-learning, numbers, pandas, parallel processing, and the DICE tool, etc., are now being used by the developers in the data generation process as well as the data validation process. I continue to be involved in this research, mainly focused in the validation area, but as I find things new, I might push it across to the developers and have a good working relationship with that side of the house as well. The NHD and all of its flavors, the current one being the NHD Plus high resolution, 1 to 24,000, 25 million lines across the contiguous USA, with Alaska still to be generated, the elevation derived hydrography in the works. So many of these things continue to be part of numerous scientific efforts, as well as applied science and resource management planning. As we progress through this century, water is going to become more and more important, and we are already seeing some of the effects of the lack of water. Cliche as it may seem, it is a genuine honor to be a small part of this generation of validation. Thanks for listening in today. If you have any questions, feel free to get hold of me or ask questions at the time of the presentation.